We are supporting multiple environment managers. We are supporting HIP. We are supporting Conda. We are supporting MicroMamba or Mamba, just Mamba.
Yep.
And we also support multiple types or multiple languages, actually. So you can run Python code, you can run Python notebooks, you can run R, you can run Bash, and you can also specify a Docker file as an input. And it will actually, the node, our worker node, will take that Docker file, build the Docker image, and run that as a work folder.
So in a nutshell, there's no limitation to what can be run through Coretex. My name is Igor Peric. I'm head of product at Coretex. I'm here with our lead software engineer, Dusko. So we're gonna walk you through one of the templates that Coretex platform supports. This one is in the area of bioinformatics. We're gonna be using QIIME2, a very popular tool in bioinformatics community. And in this case, we're gonna filter out some and analyze some of the DNA sequencing data. So with that, without further ado, Dusko, take it away.
Thanks, Igor. So let's first start by creating a new project inside Coretex for bioinformatics. So we have a specific type that is just for bioinformatics right here. So I'm gonna give the name. And I'm gonna create it. And let's start by importing the QIIME dataset. So I'm gonna be downloading the dataset from QIIME2, moving pictures tutorial from their documentation. But I have a URL already.
So this tool can be used as an independent tool completely, but we're gonna show how it's wrapped into Coretex, so you can do stuff like schedule and organize multiple experiments in QIIME versus just manually running them one after another.
Yeah, and we are gonna need multiple files from this website. So first, we are gonna need sample metadata file. So it's a metadata file containing information about all the samples inside these classical files. So, and next thing we're gonna need is the sequences and barcodes. So this is an example of multiplex sequences. And there's also demultiplex sequences, which is a list of multiple FASTQ files separated by sequences, separated by samples. And here we have to do the separation by ourselves.
So QIIME supports both multiplexed and demultiplexed analysis. In this case, it's multiplex. That's why we have barcodes.
Yes. I'm going to compress this on my system, and I'm going to go click on new data set. And right here, I'm going to enter a name, QIIME2, moving pictures. And here, I'm going to select any dataset type.
And sorry, can you just open briefly the drop down? So yes. This is a perfect example of how selecting a specific type of a project in Coretex gives you slightly different interface and user experience that is tailored to that specific project type. So if you have bioinformatics project, then you get custom importers like these. If you have computer vision project, you get image annotation tools, for example. So, and if you don't want to use those very dedicated and specific parts of the Coretex for a specific data type or a task, then you just say other, and your project can ingest any kind of data sets, but you lose some of these advanced tailored importers or data handling tools.
Yeah, exactly. So I'm going to pick the import as any because I'm not importing any of these specific types.
Yep.
So I'm just going to go here and drag and drop this right here and press on create dataset.
So right now data is being moved to our servers in this case, so it can be fetched by any kind of node that in the future you add to your organization to process this data.
So we can see right here that the data was properly imported, and I can open this data set and explore it right here. I can see whatever was contained inside that data set, and we even have custom previewers for some of the specific file types.
You can show the histogram. I think if there's point, maybe switch the chart.
Yeah.
So any table, any table can be shown as histogram or line chart. You can choose values for X and Y axis under assumption that there are some. Well, sample ID is not informative column, but some other might be. So
body site is actually
body site, for example. Yeah. So you can check the distribution of your samples according to any kind of metrics, and this is applicable for all of the tabular data. Irrelevant of the type of the project you have. And anytime you select any file on the left side, you can preview it using these tools.
Yeah. So this is how the data looks inside of Coretex. The next thing we're going to create is we're going to create a new workflow. So workflows are created to execute something. So right here, I'm going to create QIIME2 workflow. And we already have a custom list of predefined workflows, so you don't have to create every workflow from scratch by yourself.
You can if you want to. And we are working day to day with our partners to expand this list of curated, typical commonly used tasks. Those are like micro units that are part of the workflow as individual steps. And we are making them so they're modular, so they can be reused no matter what you want to do. Like you can segment, take like a couple of steps only from a workflow, link them together and execute only this piece if you want. Yeah. So what are we doing today? Are we doing the full workflow or?
We are going to do just that to workflow. Okay. So we don't do the full workflow because it's going to take a while to execute fully.
Okay, cool.
And here we are already taken to a screen which can feel a bit overwhelming at first.
So let's switch to the visual editor. So there are two views, right? So there's visual and advanced. Visual is kind of showing you what's the layout of the execution, and you can just take those boxes and move them around and see how your workflow is being fed. One output from one task is being fed into another task as an input. So you can see basically dependencies. And right there, you can kind of select the data set as the first step. You see it's red and it's not selected, right? But it's required.
And we're going to select the data set that we already created for this.
Yep.
But
so
no, go ahead.
We can switch to the advanced maybe now.
Yeah, because we need to enter other parameters that are going to be used for the workflow. So one of the first things we can notice is that we also have some of the other parameters that are red. And these are required parameters whose value must be entered. Otherwise, you will not be able to start the workflow. And here I'm going to enter the metadata file name, and we can validate here. I named it sample metadata.tsv. So I'm going to just copy this and enter it right here. Press on OK, and that's basically. You do not need to enter any of the other parameters. Well, so we don't have any other required parameter, but we actually need to enter one more, which is the barcode column, because we need to enter which column from this sample metadata.tsv needs to be used for extracting the barcodes and separating them into multiple samples.
Yeah, and all of this might be very confusing, but this is like bioinformatician would know what all of these things mean, and this would give them full control over that domain, over the thing that they want to do.
Yeah, and here I'm gonna just quickly open the metadata file and take a look at which column is the one which contains the barcodes. And here we can see it's called barcode -sequence. So I'm gonna be using that right here. And we should be good to go. There are also other types of parameters. Right here we can see these are data2 parameters for trunk length of the sequence inside the FASTQ file. And if you leave it empty, it will be automatically set by our algorithm for determining the value of these parameters. So you don't have to manually look at the chart, see where the cutoff point for FastQ quality is. You can leave that job to Coretex.
And I think it's a very good moment. Sorry, I think it's a very good moment to mention or briefly just tease and show how parameter optimization is done. If you don't know the actual value, we won't run it right now, but let's say you don't know the actual good value for one of these parameters. You could change this to a list and then specify that this is a parameter you want multiple runs for, and then Coretex is gonna spin off different workflow runs for you, each one of them having one of the values from that candidate list that you specified here. So this is one of the most loved features by Coretex users.
Yeah, so let me go and open up the.
We don't have to do it right now. We can just go ahead and go with the node selection. I think this is okay for now. So let's just go to run the schedule execution of this experiment.
Yeah, so I'm gonna go to select node right here, and I'm gonna pick one of the nodes, which is.
Sorry, let's just so there's a mixture of cloud nodes and individual on-premise nodes here. So you can see the type column, and wherever there's a small cloud, that's a queue. That's an execution queue or a cluster. And in this case, it's a 64 gigabyte machine with 16 cores hosted on AWS, but it can be hosted anywhere because we support Kubernetes deployments. And in this case, once we select this node, it's gonna get sent to the queue, and Coretex is gonna talk to that cluster and spin up a new node for our experiment to execute. And if we had this parameter optimization turned on, multiple workflows would be scheduled. So Cloud would just spin up a couple of different machines, so everything runs in parallel. For now, I think we're just gonna do one, right?
Yeah. Cool. I'm gonna select that one, and I'm gonna press on run. And right now the workflow is scheduled for execution, and we are, as we can see, its status is queued since it's waiting for that worker node to be spawned.
Awesome. Can we check the details of that thing right now before it started executing, just to see how it looks like when it's in a queue state?
There is we can right
the,
now.
The run status. So the details of the run.
The details of the run are right here. So each workflow contains multiple individual tasks, and we can see each of them created right here.
Yep.
So
can we just check one of those?
Yeah, I'm gonna open the oldest one, and it's in the queue status, and it's waiting for the worker node to be started.
Cool.
And here we can see the snapshot of the parameters that we entered.
Yeah. And then we can also see the actual code that we scheduled execution with. So it's like a snapshot of everything that was in the code base at the moment when we scheduled execution of this workflow.
Yeah, this is done to make it 100% reproducible.
Exactly. So cool. After some time, we should have the node up and running, and Coretex should execute this run, and all of the other boxes on the right side, the artifacts, the model, if exists, and the console will be showing all of the details of how the run is progressing.
Yes, so we will see basically all the output which was specified inside of that code right here inside of the Python, every single print statement, every single log which you get printed to your, for example, Visual Studio Code terminal, it will get printed to Coretex.
So it's automatically picking up all of the standard output and standard error, right?
Yes, as well also if you create something inside of the root directory or any of the child directories inside of your project which you uploaded, it will every single file will automatically get uploaded to Coretex as an artifact. So right here. And we can see right now that the status has switched to executing. So it started executing this task from the workflow. And we can see that metrics are showing up. We can see that console logs are starting to show up right here. Okay, on it for some reason.
That's cool. So it's automatically detected that one of the machines was booted up, and it started executing the run over there. So you don't have to be, waiting for a machine to be available, try to SSH, kick off the experiment, think about terminal sessions that, when you close your SSH session, it doesn't go away, things like these. And also it can send you, you get notifications when things are finished. So and optionally, you can also get results in the email with the notification and things like that. Can we scroll down just briefly to see the metrics, because there's 7 of them? And so as a download speed, upload speed, disk write and read, and things like that. And usually this is helpful to when something is going wrong or the experiment is slow and you expect it to be running faster, you can see the bottlenecks here. So you can see, for instance, you can see that the CPU usage is right now 100%. So that means that it helps you understand that if you want this experiment to run faster, you need to vertically scale this. So like boot up a better machine with more CPU cores or high CPU clock and things like that. If you see that RAM is being used excessively and then swap memory is jumping, that's a signal for you to either optimize the code or try with the lower, smaller data set, or on a machine which has more RAM. So this is kind of your dashboard or a cockpit into what's actually happening. Feeling the pulse of experiment or your run is done from this screen. So yeah, can we go briefly just to see the runs? The list of runs. So yeah, one of them is executing right now, and the other 2 are in queue. Why didn't we get 3 machines right now to run all 3 in parallel?
Well, because as we can see here on the workflow preview screen, when I go to the visual display, we can see that all 3 are connected right here. So the output data set of the first one is set as the input data set of the next one. So this one needs to finish first before the next one can even start, because it depends on its output.
Right. So Coretex knows this. Coretex is figuring out all of the time which inputs which are required are still not there. And then it kind of organizes the execution of all of those runs, which are scheduled in the most optimal way. It waits for everything to be done. And then once it's done, it immediately takes the next task and then sends it for execution.
Yeah. For example, if we didn't have this connection right here, we would have another box like this one for selecting another data set for this one. And then if we run the workflow that way, then these 2 could be executed in parallel. But this third one would need to wait.
Exactly. Yeah. Cool. And this is a good example of something going wrong in the run. Let's see what it is. See the console? What does it say?
It couldn't import the data for some reason. So it tried to run the QIIME import functionality. So it basically takes the data set that we provided and it tries to convert it to a QZA file, which is a shorthand for QIIME artifact. And it failed at that step.
Cool. And now we can go in and introspect why it failed and reschedule the run again after this.
Yeah, it was probably an issue in the formatting of the data set when I uploaded it.
Okay. Is that something we can quickly fix?
I'm not sure. I would need to look at the code as to why this failed the way it did.
Let's try to take a quick look.
Yeah, I think I can see it. I named one of the files in an invalid fashion, so this cannot be named forward. It's gotta be named sequences.fastq.gz. So I'm gonna re-upload the data set.
Yep.
Right now.
And you saw that by looking in the code. And this is a very specific example of something being hard coded, but you see how we were able to see exactly what went wrong because we were capturing all of the output and we showed it in the console. A good practice is leaving these namings and all of these things as parameters, and so the user has an option to change them during the runtime. So for instance, if you really wanted to have your file named, what was it, forward.fasta or something like that, then you should have had an option to specify that and to select that file.
Yeah.
So these templates are written this way, so there's definitely room for slight improvement there. So we are selecting the other data set now, no?
Yeah, I did the version 1, and I'm gonna quickly just confirm that this is correct. It is. And here it's barcode sequence, but let's just confirm that too by opening the dataset.
And we had a rerun feature at one point, no? So I'm not sure if it's still there with the recent changes, but cases like these would be able to be rerun faster when you select one task. And then it pre-populates all of the parameters that you previously had in there. You can just change, in this case, dataset.
Yeah. Or for example, you could do save as default right here after entering all the parameters. And when I press this, it will, when next time I open this workflow, it will reuse the same parameters. Yeah. So I'm gonna pick the same machine again. Validate that everything is correct and rerun it.
Yep. Let's give it one more go before we finish.
Yep. And this time it will start the execution faster since the Python environment has been already created during this step.
Yep.
So it will try to reuse the old environment. It will not create a new one unless you explicitly specify to do.
So it will reuse environments, Python environments between multiple runs if you don't destroy the file system, so to speak, right? If there's a persistent mechanism of storing, like in this case, because it's I'm asking because it's a cloud queue. So the machine you just ran it on, it got killed, right?
Yeah, so if the same machine isn't started, then yes, it will not use the cache.
Yeah, but in regular case, and especially in the cases of private execution where you as a company, as an organization, have your own infrastructure. You have training machines and you installed Coretex node on them. So they are connected to our infrastructure. In that case, those machines are going to have persistent storage. And when you run multiple experiments one after another, like we did just now, it's going to use the cache environment. And of course, if you change anything related to dependencies, it will update the environment itself.
Yeah, because it takes a snapshot of your dependencies in a predefined fashion.
Yeah.
So it can.
And what about environment support? What kind of environment managers are we supporting?
So we are supporting multiple environment managers. We are supporting Pip. We are supporting Conda. We are supporting MicroMamba or Mamba, just Mamba.
Yep.
And we also support multiple types or multiple languages, actually. So you can run Python code, you can run Python notebooks, you can run R, you can run Bash, and you can also specify a Docker file as an input. And it will actually, the node, our worker node, will take that Docker file, build the Docker image, and run that as a workflow.
So in a nutshell, there's no limitation to what can be run through Coretex, basically. Some things are just easier and more seamless, like Python environments, for example, or R, because we have a specific set of tools that make it easier for you. But if you have your own Docker image, you can just go ahead and specify it and run.
Yeah, and here you can see that it started executing, the machine has spawned, and we can see right here that it is using a different machine with a different IP address.
Yep.
So let's open it. Let's inspect the
Okay.
console, and we can see here that it is creating the environment from scratch.
Yeah, because it's a different machine. But that's not going to be the case when you're running inside of your intranet. When you have your own infrastructure and you don't, even if you turn off the machine and boot it up again, if the storage is persistent, you'll have it. And then what is being cached? The data sets are being cached, right?
Data sets, models, artifacts, environments, and I think that's it.
Right. And for all of those, we have collision detection and staleness detection also. So when a data set gets updated, for example, through Web UI, and you rerun one of the workflows on the same node which cached the previous version of the data set, checksums are going to be compared, and the new version will be fetched at the appropriate time. So it's going to optimize. It's not going to fetch stuff that didn't change.
Yeah, it keeps a track of all those changes.
Yeah. And that's particularly useful for things in when you're merging two different data sets or a couple of different data sets into one. You don't have to create deep copies of those. You can just merge them by reference, and then they become locked, and then they cannot be changed. So that optimizes the speed of execution, because you don't have to refetch a data set again, because you already have it cached. Even though you merge it with another data set, its caching is based on individual items of the data set.
And in this case, it is using Mamba as an environment manager. Right here, we are seeing the output of the creation of the environment using the environment.yaml file, which is defined inside the task itself.
Cool, and now it's installing the requirements now.
Yeah, so it basically finished creating the Mamba environment, and it's installing the pip packages from the requirements.
Cool. So in a nutshell, you don't have to SSH into the machine in order to figure out what's happening. You can literally command it from outside, and you also have, if you go to nodes and open that machine, you have some metrics about it. You eventually will have console output. So you will have a command interface from within Coretex to control that machine and introspect it, see what's happening. Right.
Let's go back to the line.
Yep.
And see what is going on with it. And right here, we can see that the task run finished successfully this time because the data set was correct. So this had transition to done. Cool. And the next one should be started. Yep. And we can see enter the executing state, and let's check what it's doing. So here we can see it's using cached environment. Since the first step already created an environment, it no longer needs to do that. It will just reuse that one to make it execute faster with zero downtime.
That's cool. And can we check artifacts very briefly? So we are in a second step already, but let's see. I think that they are dumped anyways at the beginning.
Yeah, we do have some artifacts right here. So it's a archive here.
Yeah.
And
so we can see the demultiplexed content. Can we briefly go to the step one artifacts and just see how that went? What was generated there?
So
it's just okay. So it's the imported versions of those. But anyways, if this is if this is something. If you have a need to output some intermediate results or actually end results like models or some kind of visualizations or charts or something like that you want to store for later use, artifacts are a perfect place for that. And as Dusko mentioned already, they are being automatically picked up by something similar to Watchman. So the file system is being analyzed continuously during the runtime, and everything that experiment creates in the root folder or anywhere below, it's going to be automatically sent to Coretex for storage, so just to keep track of what happened. So that's very convenient. And this is the third one, right?
Yeah, the first two finished successfully, and now we are on the third one. So we can see what it's doing. And it automatically picked the trunk line for forward reads at 117. So this is what we talked about at the beginning.
Yeah.
Right now it's performing the denoising using data2 algorithm from QIIME.
Cool. And we already have some artifacts.
Yeah.
So what does it say?
So it's the denoise output, and probably will be finishing up soon.
Cool. That failed with some reason.
It got rejected with the upload. So
yeah, it's a detail that needs to be, probably the experiment code was not updated to match what we have with the backend.
It was the other way around. So backend was not updated to match
okay. That's okay. That's fine. Yeah, but that's cool. I mean, we've seen how things are being uploaded and moved into Cortex Cloud, how storage is being handled, how experiments are consecutively executed and orchestrated by Cortex on the cloud infrastructure. So I believe, I don't know if there's anything else that you want to mention that is relevant, or we're good?
We are good.
Cool.
I don't think we have anything else to add.
Yeah, great. Thanks for the attention. Thank you, Dusko.
Thank you.
Join our community today and learn how to execute your ideas with confidence.